Okay. Chapter 8, Day 1. What we're going to focus on is what is the inverse of an exponential function. So I kind of mentioned in class that we're going to be working with undoing exponential functions. And how do we use it to simplify and solve exponential problems? So this will take us a little bit to go through. So first of all, an exponential function, if we look at this problem, here's a general exponential function. Y equals some number raised to the x. That's our exponential. Our exponential function looks like this. Y equals some number raised to the x. Let me bring this down just a little. Okay? The inverse of this, well, if you remember, when we take an inverse, we trade the letters x and y. But then we have to resolve for y. Okay? Graphically, if you remember, I say just plot points, switch x and y, replot them. This is what it would look like graphically. All right? Most of the time, though, we have to do it algebraically. So, to solve for y, we need to undo this exponent. Now, back when we had like a base squared, we undid it by taking the square root. Here's the problem. The base now is a number in which the variable is what the power is. And so we don't have a rule for that until today. So to solve for y, we undo the exponent by taking what's called a logarithm, or we write the word log for short. All right, so that's new, and it's used to undo exponential situations. All right, so the inverse then is to take the log of this side. And so taking the log, we just write the word log in here. This is now the base, and this is a number. Okay? And so sometimes in your test it'll say, find the inverse. That's easy. Find the inverse. All right, so here's the original function, the inverse. Put the word log in. It's that easy to find the inverse. So usually that's not what they ask all the time. They might just ask it once, like, find the inverse. Well, let's put the word log in. 7's now the base. Notice the x and the log are on the same level. 7 is dropped down below like a base. Here, find the inverse. The inverse, f inverse x, right? Find the inverse is log base 10 of x. Log, notice, this is how we say it, log base 4 of x. Log base 7 of x. Log base 10 of x. Here's a thing to know though. Base 10, log base 10 of x is written this way. So just how, if I have x to the first power, I don't write the 1. If I take the square root of x, I don't write the 2 in the root symbol. If I'm taking the log of base 10, you'll never see the 10 here. You'll just see log of x on the same level. The base is 10, all right? We don't write the base if it is 10. It's implied to be 10. We don't write it. You could always put it in though. You could always write 10 there. So the first part of this lesson is, how do we find the inverse? We find the inverse by just putting the word log in. I know it sounds kind of silly, but we just put the word log in and we've taken the inverse of that function. Okay? Now, what's the other thing? One of the things we have to be able to do is to write what we call log equivalencies. So we're trying to think about what's equivalent. And log equivalencies then. We can interchange between exponential form and log form. And when we interchange them, they are equivalent to each other. All right? So I'm not taking the inverse anymore. My next task is to rewrite it so it's the same. So remember when I would write like x to the half power, and I would say that that's equal to the square root of x? These are equivalent. This is root form and this is like fractional exponent form, okay? We're going to do the same thing but with logs. We're going to write things in equivalent forms using the word log, okay? So, we have two forms. We have exponential form and we have log form. Exponential form. X equals some base raised to the y. All right, log form. Y equals log of this base raised to the x. They are the same. All right? Notice, what does this say? This says y is the power on b that gives us the answer of x. Y is the power that's on whatever number this is, and the answer is x. Well, I read this the same way. Y is the power on b that gives us the answer of x. And so when you fully understand logs, you will fully get that when I see anything like this, I should be able to read it as this is the power of the b that gives us this answer. Okay? So, in your calculator, if you typed in log of 100, you would see the answer is 2, because 2 is the power on 10, because base 10, that gives us an answer of 100. All right? We're going to do a lot more with that in class, don't worry. So, one of the things that you have to be able to do for your exam is to switch back and forth between the forms. They will say, what is equivalent to this? So let's take a look. So if I want to go from like exponential form to log form, all right? This is the base, this is the exponent, this is the answer, all right? So what do? We have to trade the exponent and the answer. So the 8 and the y are going to switch places. I'm going to put the word log in front of the base. So what happens is these two things will trade places. So y will equal 2 to the 8th, but I got to stick the word log in. So y will equal log base 2 to the 8th. Trade exponent and answer, stick the word log in front of the base. Now, if I'm starting out in log form and I want to go to exponential form, okay, trade exponent and answer. So again, here's my exponent, here's my answer. Trade them and take the word log away. So get rid of the word log. 2 to the y equals 8. Trade them, take the word log out. This is called log form because it has the word log in it. This is called exponential form because my letter is the exponent. So when we come to class, we're going to work on trading and going back and forth between these.